Introduction to Electrodynamics by David J. Griffiths, problem number 2.12. In this problem, we have to find E field inside the solid sphere have uniform distribution rho. That is also called volume charge distribution. And then we have to compare our results with problem number 2.8. That's all our job in this particular problem. So consider an arrangement of solid sphere of uniform charge distribution. Let's take a Gaussian surface inside this arrangement. Consider here we have a center of Gaussian surface and radius of Gaussian surface from center is small r and radius of solid sphere from center is capital R. Here is important point that be noticeable for inside small r is less than capital R. To calculate E field we use integral form of Gauss's law, that is according to integral form of Gauss's law, that is close integral E dot dA, where dA is a vector area, is equal to Q enclosed over epsilon naught. We call this equation number 1. From this equation, here our first task is to calculate Q enclosed by this surface. That can be calculated by volume charge distribution, as rho is equal to charge per unit volume. In this case, charge is equal to Q and volume is equal to volume of a sphere, that is equal to 4 over 3 pi r cube. So our volume charge distribution is equal to Q 4 over 3 pi r cube, that is equal to 3Q over 4 pi r cube. We call this equation number 2. But our need is Q, so Q is equal to 4 pi r cube rho over 3. We call this equation number 3. By putting equation number 3 into equation number 1, we have close integral E dot dA is equal to 4 pi r cube rho over 3 epsilon naught. Now as charges are uniformly distributed, so E will be uniform. So we can take out E from integral, then we have E close integral dA is equal to 4 pi r cube rho over 3 epsilon naught. Here close integral dA is a area over Gaussian surface, that is equal to a 4 pi r square. We just put this expression here, then our expression is E into 4 pi r square is equal to 4 pi r cube rho over 3 epsilon naught. Here 4 pi cancel with 4 pi and r square cancel with r cube. Here r will be left. Then E will be rho r over 3 epsilon naught. And if we talk about vector form of this E, then we have r unit vector. So this is a E field inside the uniform charged solid sphere. Now we have to compare it with problem 2.8. Recall problem 2.8. In problem 2.8, we calculated E field using Coulomb's law, that is equal to E is equal to 1 over 4 pi epsilon naught q over r square r vector into r unit vector. Our task here to reduce our result into this form. So again we write our result, that is E is equal to rho r over 3 epsilon naught r unit vector. And from equation number 2, from equation 2 we have rho is equal to 3q over 4 pi r cube. Here we consider r is approximate is equal to capital R. So rho is equal to 3q over 4 pi r of cube. We just put this expression to E, then we have E is equal to 3q over 4 pi r cube into r over 3 epsilon naught into r unit vector. Then 3 will cancel with 3. We have E is equal to q over 4 pi r cube into r epsilon naught r of unit vector. So E is equal to 1 over 4 pi epsilon naught q r cube into r vector into r unit vector. But here is the difference between these two calculations. That is, when we deal with Coulomb's law, we face difficulty, but when we deal with Gauss's law, then it is more convenient than Coulomb's law. So Gauss's law is more general than Coulomb's law.